We have shown the problem of naive measurement. For example, if we simply measure before and after the grain seeds were switched, our impact evaluation could be way off. So, if we want to compare a world where the intervention happened to one in which it did not, what can we do? An intuitive answer would be to compare people who participated in an intervention to those who didn't. For example, choose a village to switch their seeds to the new ones and compare it to a village next to it that did not make the switch. This is called a control trial, because the village that did not make the change can be used as a point for comparison, or, in scientific terms, a control group. Conversely, the village that participates in the intervention is often called the experimental group, and we will simply refer to it as the intervention group. Once we have the two groups, we can compare the intervention group after the intervention starts to the control group, which did not participate in the intervention. The difference you see in each measurement is the supposed counterfactual impact, because that's what's changed between switching to the new seeds and not switching to the new seeds. Is this a good approach? Well, it's a good start, but there are still many issues with it. A major one is what's called selection bias. We really need to ask how the village that made the switch to the new seeds was selected. Maybe the researchers knew people from that village, or the researchers thought the village had many industrious people that could fully utilize the new seeds, or maybe even someone from the village reached out to the researchers to propose a collaboration. These are all extreme cases of selection bias, where the intervention is given to a non-representative sample of the population. In all the examples we gave, we would expect the village to do better than the control, even if there was no intervention at all, which of course ruins our ability to identify the actual counterfactual impact. It's worth noting, this is not solely hypothetical. We often see experiments in which those who get the intervention are significantly different than the control. To make the point even clearer, if the process by which you select the control group is biased, it doesn't even have to mean that your intervention will beat the control. The opposite may also happen, which can make you believe that an intervention is way worse than it actually is. Let's exemplify how it happens and why it's bad. Imagine the seeds intervention is offered in an area with many highly successful agricultural communities. In these circumstances, it's possible that only the less fortunate communities will register, leaving the fortunate ones as the control, meaning the control group will probably fare better than those who got the new seeds. In this case, there is actually a chance you will wrongfully believe that the intervention makes people worse off, even if it's actually helpful. So that's an issue with controlled trials, and it's not even the only one. In the next units, we'll try to think about what we can do.